This is a video for Chapter 4 in CS 121. I first want to talk about getting started with idle because we're going to play with that for the next few weeks, and you'll probably be working the next test using idle. So if you go to the link in Canvas, you can either download it for Windows or for Mac, and there's a short video to help you understand how to get these into the Windows and Mac operating systems. All Python files must have an extension of py to run in idle. So if you currently have a text file somewhere that you would like to see whether or not it runs, you'll have to change the extension on it to py. The first section in Chapter 4 in the Zybook introduces the if-else branching, and you're used to seeing if-else branching like this. The first example says a restaurant host seats patrons, and they're going to seat a party of 1 at the counter, a party of 2 is at a small table, and other size parties are seated at large tables. So there's a mental algorithm that you go through when you're trying to seat people at a restaurant. I want to introduce to you the flowchart. So there's also a file folder. So there's a file folder for Chapter 4 in here, and you can see seating arrangement.py. You can download that and play with that as we're working with idle here. Going back to the Zybooks in 4.1, there's another note here for free flowcharting online. So if I hold down Control, I can hit this link right here, and it's going to take me to the flowcharting Lucidcharts. It's a flowcharting software that's available online for free. Now I've created the flowchart for our seating arrangement here. A lot of programmers still use flowcharts or decision trees to help them to write better code. They were very important before we had personal computers because you had to punch every line of code and it had to be correctly typed every time. So it was very difficult to do coding before we had personal computers. But now that we do, the flowcharts can still be a very useful tool. The flowchart pieces and the shapes can be just pulled from the side and plopped onto the diagram. I don't want that, so I can just hit delete and it'll go away. Once you're done, you can do Control-Alt and Control-C or Command if you have a Mac. And this can be pasted right into Control-V, a Word document, or any other document, Google Doc, or wherever you're putting things like flowcharts. Now, this flowchart, there's a beginning point usually, and then there's some process that's happening in your program that takes you into a decision. The decision here is there just 1 in your party? So it's either a yes or no decision. If it's yes, then you set seat to be the counter. If it's no, are there 2 in the party? Now the decision isn't made this rigidly if you're talking to a hostess at a restaurant, but this is the actual thing that's going on. If it's 1, I'm going to go to the counter. If it's 2, I'm going to go to a small table. If it's not 2, that means it's more than 2, and I'm going to seat them at a large table. So in my program, once I know what the seat is, then I can print out, we're going to seat you at. So this is where the hostess or host would actually tell you where you're going to be seated or walk you to the table and seat you there. Now, I'm going to open up idle, and you can do that either by typing the search box at the lower left-hand corner on your computer, or actually touching the start menu and finding idle. So when I open the idle shell, this allows me to just type any code at all. So I could say x is equal to 5, y is equal to x plus 3, and then I can print x comma y. So this is functional programming, which is line by line coding. And you could do this pretty easily with this Python shell. Now, alternatively, I don't really use the Python shell that much, but occasionally I just want to see if a line works. So you can use it that way, especially as you're trying to figure out where your errors are. So instead, what I'd like to do is open up a file, and I've given you this file in Google Docs. So you can go to the folder in Google Docs. I've changed it just a little bit. In 4.1, everything they do is pseudocoding, but if I actually do the code here, the new parts are going to be this if, else if, else block. So we're going to look at this pretty carefully. But there were three choices that they gave me. If it was 1, then the counter. If it was 2, then a small table. If it was more than 2, then it was a large table. But what if my user put some weird number in? So if I'm asking you for an integer, and how many are in your party implies integer. If they give me something that's not an integer, there's going to be error in the program, and they'll get an error message. But here, if they gave me some weird number like -300, that would be allowed with an integer. So I would like for them, if they gave me something weird, to actually end up with a weird thing for their seating arrangement. So I put a crater on the moon, and often when you're programming, you might think about putting strange things in like this for programming. If someone's going to put some weird thing in, then you can play back and put some strange thing too. Now, when I opened up the seating arrangement, yours didn't have the weird part. It just had the if and elif and else. So it just was the 3 decisions that we made, like were written in the decision trait. But as you're going through, you might consider that there are things where if you put a negative number in, you would want them to have some strange answer given back to them. So my if block is if how many is less than 1. So how many is how many came in. If that's less than 1, and notice the syntax here. I've got an if, I've got what's called a boolean, B-O-O-L-E-A-N, which is going to either return true or false. If that's true, then I have a colon that's required. And then the next line is indented over, and the standard indent for Python is 4 spaces. Now, you can change a lot of options in this window. So touching options, configure idle. I can change the fonts, but I recommend you leave it as a monospaced font because it's easier to read where things are lined up and how they're lined up. You could change the standard spacing to more or less, but the Python standard is 4, so I recommend you leave that. You can change the colors that things show up. If you prefer this not to be green here, maybe you think of strings as being some other color, then you can change that. Just be careful that you're not changing one or all of them to the same color, because that kind of defeats the purpose of working in an IDE, an integrated development environment. Oh, I did forget to mention that the font here can be changed bigger, so I can make the font a lot bigger and apply it to see whether or not I like it. So a bigger font may be better for me when I'm making these videos. So I'll leave it a little bit bigger. Let's put it down at 22. Okay. So if we're working through the if, we have if and we have a colon. So in here is a decision. It's either true or false. It always has to be either true or false. So that's a boolean. We have a colon at the end. We have to indent 4 spaces. C is weird. So I could put a whole bunch of other things in here. What to do if there was an if statement there. Once I'm done with this if statement, though, I'll go to the next line. If this was false, I would skip these lines in between the if and the elif. But if it's true, then seed equals weird. If it's less than 1, seed is weird. So the elif is basically an else if, but it's ELIF is the actual code in Python. Else if doesn't work. You'll see the pseudocode says else if every time. So again, we have a boolean. The double equals is for determining whether or not something's true or false. The equals is for assigning. So some of what you'll do in this first section will be about the double equals and the equals. The colon's there again. So if this is false, it skips this line. It looks at this one. If this is false, it skips this line and looks at this one. If this is false, it skips that line, the C equals 2, and looks at the next one. If it's true, so if the first one's true, perhaps if I put that how many was -15, then it would skip all of these lines. Well, it'd say seat is weird, which puts it as a crater on the moon. So it's going to assign the string a crater on the moon to seat. And it'll skip all of these lines. So if this is true, It does the stuff directly between the if and the next elif. It does all these lines in here, which is just one in this case, and skips all the rest of these, and then it prints out that we'll seat you at the moon. To run the program, you're going to do run and run module. The shortcut of F5 on your keyboard might work, so you might get used to doing that. So when I do that, it's going to run the module in the shell here. How many are in your party? I'm going to put that -15 I was thinking about, and it's going to tell me that we'll seat you at a crater on the moon. If I go back over here and run this again, how many are in your party? I would want to go through each scenario, so if I put 1 in, we'll seat you at the counter shows up. I'll run it again. How many in your party? I'm going to put 2 in. We'll seat you at a small table. And then if I run it again, I'm going to put in 500. And it tells me that we'll seat you at a large table. So now you have the ability to work in idle. That's really all the more there is to what we're going to be doing with it. So you can type your code in here, save it on a file. It has to end in PY. When you ask it to run the file, it needs to know that it's a PY, which tells it it's a Python file, so the interpreter knows that you actually mean to interpret this as Python coding. You can run all of your files in here now, but I caution you that whenever you're working in zyBooks, you really should work within the zybook format so that I can see your progress on any particular one. I would have both of them open if I were you, because it makes it a little easier to catch your errors as you're typing. In section 4.2, they give you code instead of pseudocode. So this is actual Python coding. You can see the variable and its assignment. And the user age has an input that's coming in. It looks a lot like what we were just doing. And then it says if user age is greater than 65. So there's your first if. There's a colon after it. Anything that's between the if and the next statement that is not indented will run if user age is greater than 65 is a true statement. If it's false, then it'll skip all the stuff that's indented between the if and the next statement that is not indented. So the general if-else works like this. If expression, an expression is a Boolean expression. It has to be true or false. And then else, and some statements that it will execute when the expression was false. So the simplest if-else is if this is true, then I execute these statements. But if it's false, then I execute everything that's in the else. And there are some examples. I noticed here on the 4.2.5 participation activity, it says indent such as 3 spaces, and I would recommend that you stick with 4 because it's actually the convention. So when you're going in to type this in here, you know you're going to need an if, and you know you're going to need an else. The else here will have a colon behind it. It does not have an expression that you write. So the if here would be user age is greater than, the greater than is above the period on the keyboard, 62. The colon's necessary. Assignment item, 1, 2, 3, 4. Item discount equals 15. So don't make this difficult. Else, item discount, 1, 2, 3, 4 is 0. Now these are not double equals because you're not checking to see if it's 0. You're assigning it to be 0. So when I check this, I get, yes, I got it correct. Hooray. Now in 4.2.2, the multi-branch if-else statements is showing you that you can have an elif in between and then another else after. So the first line, the if line, so we're only really concerned with the lines that are not indented. So let's first think about those. If this line, the expression 1 is true, it'll do the next 2 statements, and then it'll skip the rest of the program. So if expression 1 is true, the first 3 lines will execute, and then it'll skip the rest. Now we've executed the first line. If it's false, If you run it and it's false, then it skips the indented lines and goes to the non-indented line here. If expression 2 is true, it'll do just the next statements that are indented. So the indenting here is pretty important for Python. It's not true for all programming languages. Some of them are a lot more complicated and need all kinds of fancy braces and things. They also talk about the equality operator here, the equals equals. I've already talked about it a little bit. That's not an assignment. That is giving a true or false statement. So either num years is actually equal to 10 or it is not. So it's either true or false. In figure 4.2.1, they show a little bit more complicated branching here, where you have if, and another elif, another elif, another elif, and an else. So if the first number of years is 1, if that's true, it's just going to print your first year, great. If that's false, then it'll go down and check it, see if it's 10, 25, or 50. And if it's not one of those, then it's nothing special, which is really not true when you're talking about wedding anniversaries. They're all pretty special. But when you're writing code, what you say there doesn't have to be true. So I'm going to work through this challenge activity in 4.2.4 and show you how I'm thinking about this when I'm actually writing it up. So I want an if-else statement with multiple branches. So that's an if, elif, 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 else, if I need that many elifs. But I can see here, this first thing, it says, this is what I'm going to do. And it says without quotes, so that's already set up the way I want it. So that's what I'm going to do first. So if that's true, 1, 2, 3, 4, I'm going to print the distant future. And this is still pseudocode because I haven't fixed the quotes yet. Otherwise, if year is 2001 or greater, I'm going to print 21st century. So that's an elif actually. That's a print 1, 2, 3, 4, and an elif. Otherwise, if year is 1901 or greater, print 20th century. So I need this back here, and then I'm going to print. So the structure looks just like English does if I just put the right indents in. So else, I want 19 or earlier, print long ago. So this is pseudocode. I can kind of see what the code should look like. I'm going to indent all of my statements within my structure. 4 spaces, because that's the standard. That's convention. So this is a lowercase if. Year is 2101 or later. Well, that is greater than or equal to, and that's written this way, with the greater than and then equal. The greater than and less than are above the comma in the period. So take a look for that. Or later. So I need a colon because that's the actual code there. Print is almost right here. I just need some parentheses and I'm good. Elif, year is 2001 or greater, so that's greater than or equal to. So this is first checking to see if it's greater than or equal to 2101, which is about 80 years from now, which puts all of y'all at about 100, and me gone. And then it checks to see if it's not larger way than that, then it's between 2001 and there. So if this is true, I'm going to print distant future. But if this is false, if this first if statement is false, then I'm going to skip the print distant future and check to see if it's greater than 2001. It's kind of like the games that you see on The Price is Right. Higher, higher, lower, lower, that kind of thing. But we're starting high and going low. So I need to finish the code here. I need colons. I need parentheses. I need an elif. If you hit the home key, it takes you to the beginning. Elif, year is 1901 or greater. So all these are greater than or equal to. This is a really typical structure for working with this if and elif. And if I'd read a little easier, I might not have put quite so many words in here, but this is fine. So I need parentheses. End will take me to the end, parentheses. And for an else, I don't need a Boolean expression in there, one that'll give me a true or false, because it's the thing I do if none of the ones above it were true. So I'm going to print long ago. So I ran it and it passed all the tests. So I had exactly what I needed there. Now the most important thing I did in going through this exercise was showing you that I'm actually following exactly what it says in English. Trying to make a decision in English is just the same as trying to make a decision in Python. But the coding here looks somewhat different because we have special words that we need to put for else if or otherwise. We don't have the word otherwise in Python. 4.3 is about nested if-else statements. And nested means that you have if-else statements within if-else statements. So if you have an if and an elif like this, you could have one line of code in here, or you could have a whole bunch of lines of codes, or you could have another if-else grouping. So this said if user choice is identically 1, and that's what this equal equals is, if it's identically 1, this gives you a true or false answer, remember, then I'm going to print something. Otherwise, if it's 2, then I want to know if the number of items is less than 0, I'll print something, or else I'll print something else. And if neither of these statements is true, it's not 1, it's not 2, then it's going to print something altogether different. You don't have to have multi-branch if-else statements. You could have one after the other, so each one of the if statements would be executed. So in this case, if the user is less than 16, we'll write this. If the user age is greater than 15, I'll write this. So if they're less than 16 and greater than 15, both of these will be written. Enjoy your early life and you are old enough to drive. If user age is greater than 17, then you'll do this one, and greater than 24. So all of these if statements will be executed one after the other. You want to be very careful when you're working with multiple if statements that either they're multi-branched with the if-else, elif statements, because they need to be, or you really do want each one of these to happen. So if you want every if statement to happen, then you want to make sure that you're not putting them in multi-branch. In 4.3.2, instead of multi-branch, you have multiple if statements. You can tell that they're not multi-branch where you're going to need an elif or an else, because each one of these stands by itself. If car year is 1969 or earlier, print. There's another if here, has nothing to do with the first one. So another if there, and then another if here. And then there's another if here. End each phrase with a period and a new line. So we're going to write multiple if statements, and I just copy these like I did before. Paste them in and separate the lines, and then you add the code. And I'll do the first one here. If needs to be lowercase. Car year is 69 or earlier, so that's is an equal to. So it's less than or equal to 69. We'll put a colon. Then we're going to print out, and notice it went to 4 lines for me there. 4 spaces rather. And we have the first one done. So these are really fast. I've already talked about the double equal operator. This is being the same as. So down here it means is A the same as B? That's what it's asking. It's a Boolean type like string, int, or float. Boolean is a type. We have one more operator in this little table. This is the not equals. You have an exclamation mark and an equals. That's a not equals. So it takes 2 symbols for not equals. Not equals means it's either less than or greater than, of course. So the relation operators are the less than or equal to, greater than or equal to. So in all we have 6 operators so far. We also have an exactly equal, the equal, and a not equal, the exclamation mark equal. 4.4.2 is only asking for the Boolean expression that goes in here. So if the value of numsense is at least $1, so then you have to interpret what does at least mean. And if I get into my 5-year-old mind, if you're going to give me at least $1, then that means that I'm expecting to get $1 at the very smallest. So you think about that as you would if you were like 5 years old. Python allows you to use a three-sided inequality like this. It's called operator chaining. So if we wanted to write a relational expression using operator chaining, x is less than y but greater than z, you can see that x would be in the middle. It's greater than z. I'm going to put a greater than over here. Z. And x is less than y. Check that and see if that works. Now I'm interested in whether or not it works the other way too, because you might have seen it the other way. Y is greater than x is greater than z. So I'm going to try that. And I see that that would also allow the operator chaining. So comparison operators here are being chained together. You have two greater thans. You could also have greater than or equal to or less than or equals here. When you're looking at the equality operator, the double equals like this, you can compare integers, characters, and strings, and they have to be exactly the same characters. So 42 is 42. A string Tuesday would have to be the same as a string with a capital Tuesday. So this would be a false if I compared those two Tuesdays. You should not compare floating types, however, because of the imprecise representation of floating point numbers. And that means that they could be off in the tenth decimal place, and they would not be considered equal. So be sure that you're comparing those carefully. The values, when you're comparing them, should be of the same type. So you could compare two integers like this. 5 is less than 2 would give you false. But you really should not compare things like 1 is less than ABC. 1 is implied to be an integer, and ABC is implied to be a string, so it would give you a type error. And you get that when you ran the program. There's a nice summary that basically says what I just said. Numbers have to be arithmetically compared. The strings are actually converted in the system, but what you need to know is that you have one string that stores something like Friday with a capital F. If it's going to be equal to another one, if it's going to be exactly the same as the other one, then it also has to be Friday with a capital F. Lists and tuples are compared via an ordered comparison, so this is important to understand. So even if they have the exact same elements in them, if they are not in the same order, then you'll end up with a false for them being equal. The Boolean would result in a false. Dictionaries are actually set, so compared with the equals and not equals. Two equal dictionaries must have the same set of keys and the same corresponding value for each key. So the order doesn't matter in a dictionary. Sometimes it can be very difficult to find common errors. So here, a really common one is to not use the double equals when you actually mean an operator that's going to result in a true or false. So comparison operator. And equals, just one equals, is an assignment. So you're assigning a variable. So here, numdogs equals 9 actually assigns numdogs to be 9. It's not Boolean. So it would generate a syntax error. The order that you put things in is very important too, and they give you some typical ones that you can't use here. Greater than or equals has to be greater than or equals, just like we say it. Not equals is the only not that we have. You can't do a not less than. Not less than is actually a greater than or equal to. And of course we don't have this one either. And I said this earlier, and there are some programming languages that use this, less than or greater than, for not equal, but Python is not one of them. So now we have a new type, Boolean, and we can assign variables to be of that type by saying whatever the variable's name is equal to either true with capital T or false with a capital F. So here they're saying my value is 5, and is small is going to be defined to be a Boolean because it's being assigned to the logical value for my val is less than 3. This is a logical expression. When you evaluate that, it's either true or false. We can look at some truth tables. Here, if we're looking at the truth table for ands, ors, or nots. These give all of the possible scenarios for A and B. So A could be false or true, and then B could either be false or true for each of those. So we've got false, 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 true, true, false, true, true. A and B, if both of them are true, you get a truth value that's true. So they both have to be true. A has to be true and B has to be true. For A or B, one of them has to be true. So notice that B is true in the second line, A is true in the first line, in the third line, and the fourth line has both of them true. So that's the truth values for the OR. A is either false or true, so not A would be exactly opposite. So then they give you a few examples here so that you can think about those logically. Table 4.5.1 has a little summary of these Boolean operators. I strongly recommend that you spend time with these tables of examples. This 4.5.2 shows you how these operators work. So you want to really think about what these things would mean. This means age is greater than 16 and age is less than 25. I want it in between those two. It can't be equal to 16. It can't be equal to 25. Note here that less than and greater than is the same as writing between two numbers. When you say between, you don't mean to include either of those. If you want to include, usually the word inclusive is used. The challenge activity 4.5.2 only wants one line of code. Notice here that they want to know if these are the numbers that are stored in your special number variable. There's already a hint. It says OR. So this should be pretty straightforward. Just one line of code. Don't overthink it. The next challenge activity is pretty much the same kind of thing. It says user age is greater than 17 and not equal to 25. Remember that the not equals is an exclamation mark equals. One line of code. In 4.5.4, they give you an example of how you might get Boolean input. So here, if the user puts in anything other than capital T, R, U, E, just like this, then this would be a false statement. So young would be false. The same is true for famous. So if you're wanting them to put in true, you'll have to ask a question, true or false, and actually have them put in a true or false, and then compare it to get out the Boolean value for your variable. In section 4.6, we're looking at membership operators. So we had the double equals, the not equals, less than or equal to, ands, ors, not. And now we're looking at things for list. So prices here is a list. And we can print 15 in prices. 15 in prices is looking to see if 15 is in the list of prices, and it is, so it'll print out true. If instead we had put 20 here, and not this expression, the string here, but just the number 20 is 20 in prices, we would have gotten a false there. Another thing we could put is a not in. If we were looking for 20 as an integer not in prices, that would give us a true. So these are not always intuitive in your head. You have to think about what you've done. Double negatives is what you want to stay away from. Figure 4.6.1 gives you an example of these membership operators. So you can see here's where the membership operator is. That's it. The rest of it's code that we kind of become familiar with. So we're first assigning a list to a variable. Then we're asking for an input from the user. And then we'll check the list to see if their name is in that list. If it's found, they'll say that the name is on the roster. And if it's not found in that list, then we'll say that we couldn't find the name on the roster. So the second one here is pretty much the same code, but instead they're using the membership operator of not in. So the logic is exactly backwards. So when you're trying to decide which one of these to use, which one you want to be true most often is the one you want to put first. So when you check a name, you're not expecting it to be there. You say, I can't find it, because then you wouldn't even have to look at the second line here. So the program would run faster, especially if you have a whole bunch of things to check in a program. You'd want to make sure the program would run faster. You can also check to see with the membership operator, the in, if a particular part of a string is contained within the whole string. So we call this a substring. So this part right here, the backslash 1.1, it's going to check to see if it's in there, and then it's going to print it out if it is. And if it's not, then it won't. So if this one is another one they're saying is not in HTTPS, and that is the HTTP secure one. So you see this HTTP? HTTPS says there's some security features that are added to it, and that's what you want to see when you're looking at websites. So for the dictionary, when you're looking to see if something's in a dictionary, it only checks the key. It doesn't care what the value is. So it's only checking to see that the key exists in the dictionary. So to check the value, you'd have to do something else. We've mentioned objects several times in the first 3 chapters, but here, knowing whether or not x and y are the same value is not the same as knowing whether or not they're the exact same object. So 2 different names could be assigned to the same object, and that's what the is or is not is looking for. It's an identity operator for objects. So in figure 4.6.4, they give you an example of the identity operator here. X and Y are both assigned the same value, but they are not the same object. So there's a second object that's created. Here, Z is assigned to be X. So they bind Z to the same object. And you might have seen this in some of the things you were looking at, because if now I change X, Z will also be changed. So even though with this code, all 3 of these have the exact same value of 1,000, Z and X are actually the same object, and you'll see that's true. They're bound to the same object. But Z and Y, even though they have the same value, are not bound to the same object. For 4.6.2, they only want 1 line of code here. So basically it's saying, is special number -99, or is special number 0, or is special number 44? The order of operations in mathematics is pretty important. You remember PEMDAS? We have the same order when we're working through the precedent in Python. But in addition to PEMDAS, we don't have just addition, subtraction, multiplication, and division. We have a whole lot more. So the precedent rules are going to be pretty important. I would recommend highly that you put in more parentheses so that your precedence is exactly what you think it is, instead of relying on remembering the rules for arithmetic and logical operators. But you could just remember the rules and make sure that you put your logical statements together pretty carefully. So we definitely have parentheses first, and then the precedence rules are just like they are for multiplication and division. We did these in an earlier section in one of the previous chapters. The relational inequality membership operators are these. So this list is basically going parentheses, the regular stuff you have with the operator of the percent thrown in, the modulus thrown in, and then it tells you what orders things will be done after that. So if you have x is less than 2, it's showing you that this is going to be done before the or, because the or shows up down here. The ands will be done before the or, the not will be done before the or. So I strongly caution you that when you're working on putting a line together like this, that you put in parentheses where you imply them to be. So if you expect to do this part first, then you want to put those around parentheses like they did here, because it's hard to see that that's going to be done first unless you remember that and comes before or when you're trying to calculate the logical value for an expression. 4.7.1 is actually looking at the precedence rules with the logical tree. Now, we were looking at flowcharts earlier, so this looks kind of like that, but when you look at a logical tree here, you're going to start at the tips of the branches and work your way in. So the first things that are done are x plus 1, y times z, and z is identically 3. So you can see those at the tips of branches. Then you work your way up the branch. We actually added 7 and 1 here, so it's giving that on the branch. And then we want to determine whether that is greater than what the value of y times z is. And it determined that it was false. So this side of the tree is done before the or, because of the precedence rules. Now if I was doing this, I would make sure that I put parentheses around this whole thing if I wanted that to be done first, because it's going to be easier for me to understand without having to double take or triple take to figure out exactly what I meant to write there. The participation activity 4.7.3 gives you a little more practice and some common errors here. So understanding the precedence is really important, but it's good practice to use parentheses. So you know exactly what you wanted to do, what your intentions were for the order of operations in your expression. So we're going to have to be careful with the mixing of tabs and spaces. So 4.8 talks about code blocks and indentation. In IDLE, the IDE that we're using, and we could be using just a regular notepad to do our coding. But as we're using idle, it automatically goes to 4 spaces when you do an if block, and then you have to go back to the beginning of the line, space back to the beginning of the line so that you get to the beginning. But it's a common error that if you mix the whole idea of tabs and spaces, you're going to end up with some problems. So I would make it 4 spaces every time. Adopt a convention. Make sure that you're indenting 4 spaces anytime you mean to in a block. We've already looked at these if statements with blocks. This one's a nested if down here. So this whole block of code would have to be done before you went on to the next line of code. The first one, year is less than 1970. That's a logical expression. It's going to return true or false. If it's true, then you do the code that's in between there and the next if. All these hashtags are, of course, in 4.8.1, I can't see all the code and I have to scroll over. So I'm going to do a Control A, and that highlights everything in that block. And then a Control C for copy, or Command if you're using a Mac. And then over here on idle, I'm going to open a new file. So File, New File. And make it the right size for my block. I haven't titled it yet. Control V. I am going to title it. I'm going to put File, Save As. I'm going to save it to where I want it, and I'm putting everything in a folder in my documents, so I'll have it pinned over here. There's a default that your computer's going to set up to go to save your files, and you can of course save them there. But here I want to save them in my programming projects, and I'm going to call this XIDE 4.8.1. See if it lets me get away with that. Now it should put the .py at the end of it, and you can see up here it did that. So from this line, XIDE 4.8.1.py. So I've changed the font so that I can see it a little better, and now I'm going to look at the actual program here. It says to import math, and then it has some variables and assignments. Then it wants to get a radius meters in, so it's asking for float input, and that looks good. Then we're just putting a blank line in. That print is blank line. If the radius meters is less than, so what you just got in is that, then the escape velocity per second is 0. So no escape velocity. In print Houston, we have a problem. Else, standard gravity parameters is grav constant, so it's going to get your stand gravity into a formula, and escape velocity is mass square root. It looks like all of the code is actually good. But if I run this, run module, unexpected indent. So it's going to show me some things like there's an unexpected indent there. So I'd say OK. So let's take that out. So there's some more indentation here that I shouldn't have, and I could keep running the thing and seeing where the next error is. And it says the next error is that. So let's actually fix these indents. So this error here needs to go back to the beginning. The print needs to go back to the beginning. These are not blocks of code. These are just individual lines. It's functional programming. It does one line at a time. And then the if statement is fine, but I need 4 spaces in here. 1, 2, 3, 4. That looks good. And it needs to be actual. That looked like it was tab. 1, 2, 3, 4. And then this should be, that probably was okay. But I want to put 4 in there. Then the else should not be indented. So we come back this way, and these should be 4 spaces indented. 1, 2, 3, 4. Not tabs. 1, 2, 3, 4. And print thrust to, that was a tab. 1, 2, 3, 4. So that's what I should have to do. Now, I also don't like that I can't see the end over here. So there are places you can break the line. So let's run this and make sure it works, and then I'll show you a little better about how it breaks. Enter the distance from the center to the earth, so I'll put 45. Houston, we have a problem. So we go back to the program. I want to break this line here, and I'm going to do it right after this string. Notice that it puts another indent on this for me automatically in idle. So idle will help you understand where your indents need to be. Make sure that when you're working in idle that you copy and paste in here regularly into your XIBooks and run things there, because this does not give you a grade. So I don't grade any of this that you're doing in idle. This is just a tool you're going to use, one that's going to be very useful to you, because if you were actually programming out in the world, you'd be using some integrated development environment like idle. So I'm going to run this again, see what it looks like. And I'm going to put distance from the Earth, this may be 1 million. 1, 2, 3, 4, 5, 6. Houston, we have a problem. Still not big enough. So I'm going to run it again. One, 2, 3, 4, 5, 6, 7, 8, 9, 10. Thrust to 282 meters per second to escape these earthly shackles. All right. So you can see when I indented this, there was no problem in putting that break there. So let's play with this a little bit more. If I put a break in the middle of the string, let's see if it doesn't like that. So if I put a break in the middle here, it's not going to run. So Python doesn't like it when you put a break in the middle of the string. So the way that you could combat that would be to put maybe a plus here. We'll try that. So it didn't have any trouble with that one, but I also lost one of my spaces. So be careful when you're breaking things like that, when you're breaking lines. So I lost a space, I need to put a space in. Now another way I could have kept the space was to put a comma in here. So let's put a comma. And we'll get rid of the plus in the space. And run that again. So it started, no problem with that one either. We'll see what it looks like. So else, we want a bigger, so we put in a bunch of zeros here. Thrust to escape these earthly shackles. So that line still looks good. So just a little lesson there about how you can break lines when you're working with the print statements in particular, but any other of the other ones you could have broken lines also. So after the equals sign here, there shouldn't be any problem with breaking that. It's still in the same block. You see the indentation didn't go in for this one, so it may not work. Let's try it. And it didn't like that one. So it's not going to let you break a line right after the equal sign. What about right before the equal sign? Control Z undoes what I did. So if I put it before the equal sign, it still doesn't let me break it. Let's see if I move the indentation, see if that works. Run module. Still doesn't work. So there's some issues here with breaking a line around an equal sign. Make sure you're aware of that as you're writing your code. Can we break it on the dot? Still can't break it on the dot there. So there's just some issues with breaking the code. And if I break it after the parentheses, notice that it indented there. So that gives me kind of an understanding of where I might be able to break this line. Would I be able to break it somewhere in the middle of the parameter? No. So just pay attention to where you're breaking line. Figure 4.8.2 gives you some more insight into how you can indent or continue a line. 4.8.3 shows you how you might indent a list or a dictionary that's a multi-line construct. So we've seen these already. We've seen these in some of the previous chapters. In 4.8.1, they're asking you to fix the program, and I recommend highly that you try to fix it here, because that's how you're going to be able to find errors in code, especially on my test. But again, you have the use of idle that you can put these lines of code into. You'd have to also copy the lines that are already there that give you the list. This is the dictionary that you're going to be working with. I'll begin the second video for chapter 4 in section 4.9 using the conditional expressions.